I got it. There it is.
You ready?
Sure.
So I'll try to remember to look at the right thing.
Okay, so we're just gonna start.
What Asf does can be best encapsulated by using our mission statement that we've had for years now, and that's making remote sensing data accessible.
ASF means a great deal to this university. It's a key part of what makes us one of the world's leading research universities.
They're very skilled, very talented, and most importantly, passionate about the work that we do.
So I think ASF is unique from its peers, partially because of our geography. That's the original reason we were put here.
It's at a great location. 11 out of 14 orbits for polar orbiting satellites come right overhead every day.
The satellite, as it's orbiting the Earth, is sending out pulses down to the Earth and having them reflect back to the satellite, which is receiving those backscatters from the ground. You can see things in SAR data that you can't really see in an optical image because it's radar. It penetrates a little bit into the soil and can bring out some substructure.
It does a really good job of reflecting off of water, so water detection, water masks, flooding, forest fire scars, crop classification. Scientists use it to monitor sea ice, for ice flows, for glacial retreat or advancement, deforestation. There is literally hundreds and hundreds of applications for SAR. One of the really neat ones is using a technique called interferometry, where you can take a time series of SAR images over the exact same location, but in different times, and then you can compare them and get a difference between those two images. And using that technique, you can see changes on the order of millimeters from hundreds of kilometers in space. That's very useful for landslides, for earthquakes, and seeing the change that is happening on the Earth's surface from very far away.
One component of ASF's day-to-day job is the so-called Asdf ground station. As part of the ground station, we are operating NASA assets, satellite dishes here in Fairbanks, and they're used for communicating with NASA-owned and NASA-related spacecraft in space. So what we do is we uplink commands to these spacecraft so that they can change imaging modes or acquisition modes, and we also downlink these data sets into either ASF's archives or other archives that NASA operates around the United States.
So our antenna systems are fully automated. We have software that controls every aspect of the antenna, tracking of the antenna movement, uplink and downlink.
Another branch of ASF is what we call the ASF Enterprise.
We have a series of Yagi antennas and 2 university-owned antenna systems out there that are large parabolics, 7-meter and a 9-meter antenna, and we can downlink and uplink S-band and X-band frequency data for customers from their own satellites.
ASF Enterprise offers space communication services to our potential customers. They can be commercial entities, they can be academic institutions, they can be government organizations. ASF is part of a geodata cooperative. It's a group of government, commercial, and academic organizations.
ASF is an important component of the entire NASA network. It's well known within the Earth observation community, both nationally and internationally. And I think ASF helps carry that name, UAF, out to the communities.
ASF serves as a resource. It's a resource to federal agencies, it's a resource to state agencies, but it's a resource to all of our faculty, staff, and students.
We are benefiting from the university quite a bit, and I think we give back reputation, we give back job opportunities, and opportunities for students at UAF to develop new skills.
We bring in about $20 million per year to the Fairbanks community and to the UAF community. So there are many ways that helps our local economy as well.
We see ourselves as part of the community. We participate in fundraisers, we participate in local organizations, and we see ourselves as just a part of this community that is the interior of Alaska.